have producers which send messages, and you have different consumers which can consume messages at the speed they want in real time or in batch or in the night, and they can consume which is later. And another whole group is
it's like failover from scalability.
All these things why you use a Kafka already as a scalable messaging system. So the last part about Kafka, I mean, we also don't have to talk more about how well it scales and how it works and other topics. You can read from so many topics about workflows. For example, this year again, you can talk about it. What we mean today, I would already focusing over 4.5 trillion messages per day. So that's a lot. So it really scales well. On the other side, Netflix also presented this year that they peak times process over 6 gigabytes per day. So that's also a lot. And then you can see there is no proof of concept here if you think about such a scale like we use. Because if you have more than that, then you will read about the using it also. So that's just the background about Kafka, so we don't have to worry about scalability, but more about what you can do with it. And so Kafka, very good. And it's the log in the middle, and then you have the user and the consumer. And in the meantime, even just the open source detection Kafka project has more. It has a connector, so it can integrate different systems, and it has a streaming engine. So even today, many people do not actually Kafka, but just think about the messaging world within the node. Even though you have Kafka connector and integration, with things like databases or messaging systems, or Elasticsearch, or Hadoop, and many more. Leveraging all the features of Kafka under the hood of the system. And the same is also true for Kafka streams, where you can build stream processing applications based on action. And that's so important because today I introduced the KSQL today. KSQL itself is based on top of Kafka. You won't see that when you write the code because you just write some SQL code, but you have all the power and the scalability of Kafka streams in KSQL. That's what we have to progress. And that's the end concept we will talk about today. So, almost all you know Kafka, but it's good because I don't know what you can do. And also for this one, I don't know what about Kafka. I will really focus on Kafka streams and then the KSQL layer on top. That's more or less the introduction. And now, as I said, KSQL is based on Kafka streams. So it's really important to understand Kafka streams first. What it is, how it's used, what it's implemented. Because KSQL has the same advantages. And if you want to go into much more detail, it also works really not just the KSQL implementation, forums, backend, and so on, but really also the Kafka streams. Because they're also relevant for this. So Kafka streams, as I said, it's part of the ENG Kafka. You can download it from the ENG website. Kafka streams is already included in that project, like Kafka Connect. It's not an additional project, it's part of the And what is it for? So in the end, the goal is to process data in different ways. So in many applications, you request response and you send some request and you get the processing and get some results. Right? Web services or so, or HTTP, that comes from what you request information. What we want to do today in many modern use cases is more flexible to get a we often have to process the data while it is evolving. So we do not want to first store it in the database, but we directly want to process the data continuously. And that's more or less what the stream works. Or some other buzzwords like streaming analytics. No matter which term you use, the goal is to continue to process the data while it is in motion. That's the important thing. So think about use cases like fraud detection, you want to process the data before the fraud is happening. Because if you store in a database, and you find out a day later, or maybe 10 minutes later, the fraud already happened, then it's too late. So you want to continue to store. The same for cross-selling. You want to cross-sell something before the customer has left the store to go to the company. Or you want to predict maintenance and replace a part of the machine before it breaks, not after. That's a common use case, and there are so many more where you would have to process the data while it's in motion without storing the database and processing the data. That's the main idea of stream processing. There are different frameworks available for that, like Flink or Star Streaming. We will focus on Kafka streams, and we are also going to a little bit more detail about how it works. So, first of all, stream processing, the main goal is to implement features. And this, for example, is a feature process each unified data. Method is Kafka as a key data store, as a data record, and you continuously want to store the data. Either each by itself, or you want to aggregate them. Analysis or aggregation. Now the key point of Kafka Streams is that you don't use another data.
עכשיו, אתה שומע? לא, שומעים, ככה שומעים, שנייה, נראה לך איך שומעים. שנייה, נראה לך איך שומעים. שנייה. ככה שומעים, אני חושב. לא זה הצפצוף הזה. צפצוף רגע.
And therefore you can also run them wherever you want. So again, you don't have to want the data cluster. But one of these things might here a little bit more old style is the var file and Java EE application and run Kafka Streams processes inside this Java application. On the other side, you might have a new project or
טוב, היה אצלי בעיה, סידרתי.
or maybe just a Docker container which you start working with. So that doesn't matter from Kafka perspective. You just build your application, focus on the business logic and run it where you want and scale it in the way you want with the technology under the hood which you want to use for that. That's the main idea of Kafka Streams, and that's really the key difference to all the other ones like Flink and Spark Streaming and so on. It's a trade-off. You have to think about, do you want one big data cluster and deploy everything there, or do you want to be independent and just focus on your business application, independent of each other one? That's more or less the key difference. And the key point then is that Kafka Streams is based on Kafka. So it leverages all the features under the hood: high volume throughput processing, scalability, failover with replication and all these things. That's all also built into Kafka Streams. And therefore, the funny thing is, 90% of the projects I see with Flink and Spark Streaming and so on, they use Kafka for data ingestion anyway, right? So it's there already. And so for some use cases, it might be simpler or easier to just build a small streaming application with Kafka Streams instead of yet another one on the big data cluster. But it's always the trade-off you have to evaluate for each project by yourself. And then you have Kafka Streams with a processor topology like you see here, and different stream processors, like filtering or aggregations or whatever you want to do in one of these things. And with that, you build then in the end your topology, which you deploy to the runtime or run afterwards. So that's the high level. And then on a deeper level, in the background, you probably can't even read everything anymore. The point here really is, under the hood, there is really some smart implementation. So I can't explain you every detail. That's what our engineers can, and they can fortunately also fix some things if something's broken or you have to optimize something. But the main thing still is that you have all the distributed complexity of Kafka under the hood, like the partitions of the input topic or the output topic. And in the middle, you process data. With Kafka Streams, you have input data from topics. You process it, filter, transform, aggregate, or whatever. And then you have output topics where the results go into the partitions. The Kafka Streams applications also has intermediate topics for doing things like aggregations. And it also
transform, aggregate, or whatever, and then you have output.
And the main one, now let's go back to a higher level, is that it's still distributed state. So you can see much more, and if one of the instances goes down, that's no problem, because Kafka is low. But also we are Kafka. And that's a very smart thing. Look at distributed processing. One goes down, and then you can see And then, of course, you can scale it up and down. Dynamic thing. So you can use start with a single sentence and then you can add more dynamic manually or automated script or you can subtract it. That's the way how it works. And then, let's say, here's a user right now. They have, for example, 10 and then comes Christmas and you sell much more, so you need more processing. So you scale up to 20 or you use 30. And it works well. After Christmas, you go back down. Under the hood, that's also important.
Bomba.
Better in the background. Okay. So under the hood, Kafka Stream stores the data locally in memory for fast access, but also on local disk if you want. It uses RocksDB, an open source key value store under the hood, so you can also store it on disk if needed or wanted. And again, it replicates also to a Kafka topic for resiliency. If one node goes down and you want to start another one which starts there again. That's more or less the power of Kafka Streams described in a few slides. And also, one more important concept of Kafka Streams is the stream and table design. So we already discussed you have streams, that's one event by itself which is processed. But on the other side, you typically also need some kind of state like in a table, or in this case, materialized view, it's what we are calling it. And here you see a stream of data, and the stream of data is also stored in a table. But the point here is, in Kafka Streams, that's really a first-class citizen of Kafka Streams. So you don't have to use an external database like a key value store or like an Oracle database. It's part of the Kafka Streams. And therefore, you can also manage state easily. And we will see the same concepts in Kafka's in KSQL later. And that makes it very easy to build even more powerful application by combining the concept of streams and tables within Kafka Streams, and later also then within KSQL. So here you see a little bit more advanced example. So here again we see a stream with inserts and deletes and updates. It stores it into a K table, into a materialized view. And this can again then be joined with another stream, right? So here you have facts and join them with this dimensions table and get an enriched stream. So that's the main idea how you build stream processing. You combine streams and tables all the time. And with that you can build very powerful streaming applications without needing external stores or databases. So this makes it much more easy to process data in motion because you don't have this request response thinking to a database. So here you see one example of a K-stream. That's in the end here how you read data from Kafka with one line of code and then how you transform it. In the end it's Java code, right? So if you want to build powerful application, it also gets more complex. You have to understand the concepts under the hood. And also the other thing is the K-table. In the end, you have to learn the API of the framework, of course. That's similar to Spark Streaming or Flink. You have to understand what is the API, what's the features, and how do you implement that in code, and how do you test that, debug that, and then deploy that in the end. So that's the same, but the key point really here is, and remember we are here for KSQL today, but the real point here about Kafka Streams is that this is Java code. So Kafka Streams is a char, it's a Java code which you implement with the API, and this is one example of that. So here, if we build one Kafka Streams application, we do some app configuration. That's a lot of Kafka similar stuff, like configuring the serializer and deserializer. And then the key point is the business logic, the processing. Right? Here you can do the filtering, transformations, aggregations, whatever you want to do in your streaming application. And then you start processing, and that's it. So this is, in the end, the code which you deploy as Kafka Streams application in a scalable way. So you can start one instance or 3 or 10 and dynamically scale it up and down. It's using Kafka under the hood and leverages all its features, also for Kafka Streams. And that's already pretty powerful, but still lightweight and simple. You can run that in a Java application, in a Docker container, in Kubernetes, wherever you want to run that. And that was, I know, a very short introduction to Kafka Stream, so if you have never heard of that, so it's already a lot of input for you, I know that. But still it's important because that's now really also the foundation for KSQL. That's very important to understand. And so let's talk a little bit about why did Confluent now build KSQL in the end, right? We have Kafka Streams, it's very powerful and it's great, that's true. But the problem is Kafka Streams is only for some part of people or audience. So it's for core developers. It's writing Java code, and it's not the simplest Java code because it's distributed processing. And so you have to be at least average developer, I would say. So it's not that easy, right? And but for that, it's also fine. So if you want to write code, and for some maybe even more complex example, it's the best solution to use Kafka Stream. So it's a great framework, but it's Java code. So it's not for non-developers, and it's also not for developers of Python or .NET or whatever other technology you use. So what we did, we built KSQL in the end to create a new expanded realm of how you build stream processing on top of Apache Kafka. That was the main motivation to do that. Right? As you see here, it's also important. This is still not for BI analysts. So it's not just you type SQL into Tableau or whatever and get a result back. That's not the main idea of that. The main idea of KSQL is that you still build streaming applications which continuously process data in a scalable way based on top of Kafka. But you don't write the code anymore in Java, but you write SQL-like queries. That was the motivation. And of course, it has its trade-offs. So here you see the most flexibility, of course, is if you write your own streaming engine with just the Kafka producers and consumers, right? That's very low level, and in some cases it might make sense. In most scenarios, you probably want to use Kafka Streams because it's a huge, big wrapper in terms of functionality around the producers and consumers. So you can do things like filtering, transformation, aggregation, sliding windows, all of these things out of the box and all that. And then, of course, there is KSQL where you just write the SQL-like queries. So that's all the trade-offs. Here you have the most flexibility, and here you have the most best simplicity. And you have to choose the right tool for your choice. We see already a lot of adoption of KSQL in the meantime for some use cases, not for all use cases, of course. So here is now a few use cases of what you can do with KSQL. One which is really pretty intuitive and simple to use for the beginning. If you just want to do streaming ETL, right? So we see more and more customers which are moving away from doing just batch processing for integration things, but wanna, while they stream the data, they also want to transform it and load it into another database or whatever the database is. It can also be a real-time system. It's not everything is batch anymore. And for that, you can do Kafka Streams and write code, or you just create one stream with a SQL command. Here, the stream is create SQL. I create stream whip actions. And you select a user ID and a page and an action from a click stream, and you do a join with the user information and filter by platinum. So in this case, we have a filter, and that's in the end the streaming ETL. We filter only the platinum people and send it to the next topic, to the next Kafka topic. And from there, you can do the next thing. Either another KSQL application or something else with Java or any other consumer which consumes from Kafka. Another example, this is a little bit more powerful then, so you can do many things like analytics, like anomaly detection. Here now we create a table, possible fraud. Of course, this is hello world, right? So in reality, it's a little bit a more complex query, what you want to do in real world. But here we select the credit card number and count. So it's a continuous process which counts from some information for a window of 5 minutes. And in this 5-minute window, if we have more than 3 payments, then we say, okay, this is probably fraud. And then we can send it, for example, to an alert topic where someone else processes it, like another machine, or we stop the payment, or whatever other business logic you want to implement. But this is how you can implement very powerful things, because this is really now already an aggregation, a sliding window, which continuously processes the data in real time and aggregates always the last 5 minutes to detect something like a count. Real-time warning is an example we see also more and more, where you simply, again, do things like aggregations and windows, and then send it to a UI to do monitoring. I will also show that a lot in the second demo then, where you see many different queries and joins and how to aggregate that and push that towards a live UI. On the other side, you can also do very technical stuff in the end. So as most of you know Kafka well, sometimes you have problems. For example, you need to migrate a topic to a new one because of partitioning and so on, right? And then you can also do that with a query. There's many different things you can do. Or another example, you can easily convert between data formats. So let's assume that your incoming topic has just JSON data, but for something else you need Afro data. So you can do that with code or with a Kafka Streams application, or you write just one line of KSQL code. So here we first have incoming data, which is JSON, and it has some structure, in this case from a sensor. I will go into more detail here later if you don't understand that yet. But the goal is here we have a stream which has JSON data, and then we create another stream which converts that to Afro. And that's done by selecting from the JSON data, and it automatically converts that to Afro. So I will show you that in the live demo also.
Question about the conversion to Afro. How do you determine the schema?
The schema, the question is how do you determine the schema in this case, because here you didn't have to add it, and that's because the schema is already here, so we know it already from this stream. I will show that in the live demo. So when you create a new stream with JSON, you have to here define the structure of the schema. And so this is then using the same structure like this, but converts it to an Afro topic. So also very important, what's KSQL not? That's also very important because we get these questions all the time. And that's more or less because of the foundation of what Kafka is. So it's not for powerful ad hoc queries. So as you know, Kafka is a log. It's a dump thing where you store binaries in the end. So you cannot do complex queries like in an Oracle database with hundreds of joins and whatever. That's not what it is built for. That's not the goal of it, right? And also, therefore, it doesn't really make much sense to integrate it with traditional BI tools like Tableau or Qlik. The reason for that, again, and that's very important to understand. So Kafka is a streaming platform. It continuously processes events. So that's not built for a static batch tool like Tableau or other BI tools where you do a request and get a response back. And that's the reason why it doesn't really make sense to integrate with that, because these tools are also not built to consume hundreds or even thousands or millions of events to show them in a BI tool which is built for batch where you sometimes do a request once. And therefore, that doesn't really make sense. If you really want to go into this direction to have BI things, there is other tools which really integrate the streaming data. So there's a lot of products on the market. I don't even want to mention some, but you will find several ones, and some of them actually already integrate with KSQL already. And therefore, you have then a streaming UI, which is also live. That makes much more sense. But remember, really, as Kafka is a streaming platform, you have to rethink it for other use cases than the request-response model, right? So with that, let's talk a little bit more about the KSQL concepts, and then I will also show the first live demo. Again, this is based on KSQL, based on Kafka Streams. And with that, similar to Kafka Streams, it's really important, we mean that. It's built for any kind of use case. You can do that on your laptop, like I will do in a minute in the live demo. But you can scale that up to a production system, and you can even scale it out. Really, we see it the same way like Kafka Streams. For mission-critical systems, and we expect that our customers run that 24/7 with zero downtime and with our support. And it's already GA, so you can start it now. And if you're our subscription customer, we will already support you with that. It's not meant just for interactive analysis, which you can also do. I will show you. That's great. But you can deploy that into scalable mission-critical production systems. But the difference is you don't write the Java code, but just SQL commands and deploy them. We will see that after the first live demo, what that means really to deploy them and how do you do that. So here is two more examples what we mean with it scales well and it's built for different use cases. And there are similar numbers for Kafka Streams, but here I have two examples, and we have some more measurements and analysis, and we will hopefully also publicly show all of them soon. But here is one example. This is a simple query, a filter query. With KSQL, and here you see the first lines are the most important ones. So here we have a cluster size of 3. So that means we have 3 engines where KSQL is running and processing the data continuously. And here we have 585,000 messages per second, right? So, and we have a cluster size of 3. So that's probably very small messages here or fine-tuned or whatever. The count itself is not the point. The point is now if we scale that to 10, you get exactly what you expect. So here you get around 1.8 million messages per second. So you see it scales very well. And you could even scale that then to 20 or 30, and it will still scale well in the same way. And the same, here's an aggregation. Aggregation is more computation and so on. So here you see again a cluster of 3. In this case, it's 157,000 processed messages per second. And with 10, then you get 538,000. So it scales in the same way. This is just 2 examples, and we also recommend do your own measurements and analysis how that works for you. But we expect for the common applications in KSQL that it scales in the same way like Kafka streams.
Regarding the cluster size, do you mean KSQL cluster or the integrated inside of Kafka?
Yes, this is the KSQL cluster. I will talk about the architecture about that after the first live demo. It's really also important, I have that later somewhere in red. KSQL engines are independent of the Kafka cluster. It's just a client in the end, and that's the engine, and there you put your queries in. We will see that later how that works.
One more question regarding failover. If you have like in start, storm, checkpoints, if I have an ongoing query which join, which fails.
Yeah.
If I need to restart it, you know how to continue from the same spot.
Yeah. So the question was about checkpointing and so on, so similar to Spark or so. To be honest, I also don't know these frameworks in much detail. But the point is with Kafka, with KSQL, similar to Kafka streams, you have under the hood the Kafka topic, where it also stores the offsets and the consumption and so on. And with that, you also have this failover. So that means if you have, in this case, 10 instances, and during the processing one goes down, then Kafka realizes that, and also it knows because of the offsets where to restart on a new instance. And that's in the end what Kafka, the protocol, and the broker, and also then the framework with Kafka streams implements under the hood, right? Here again, I really cannot tell you the deep dive how that works under the hood, but I know that it works, and that's the important thing for the end user which wants to use the technology. But it's also documented on our documentation if you want to learn much more into how that works under the hood. So here again, same story as for Kafka streams. You can run it anywhere, locally in a Java process or via Kubernetes or so. That's the same story because under the hood it's a Kafka streams engine. And also again for the independence, you develop just your application and don't focus on the big data cluster. So one more time to point out, so the goal is really that you don't have to write source code. That's the main reason why we built KSQL as alternative to Kafka streams. So you don't have to think about things like serialization, generics, lambdas, and all these things you use in Java code. On the other side, you have all the Kafka magic out of the box. So you can use things like exactly once processing. You have the different windows from Kafka streams. You have all the features. Also, the last one is very important: distributed, fault-tolerant scalability. Right? All what you know from Kafka and Kafka streams, the same is all true for KSQL. And we support it mission critical 24/7. So we really mean it for that. And also, like Kafka streams, very important is the concept of streams and tables. And so let's think about this more, again, because we also see it in the demo in a minute. And it's really one of these concepts where some people struggle in the beginning a little bit with. It's in the end pretty simple. You have the streams, Alice1, Charlie1, Alice2, Bob1. That's everything is one independent event which is processed. And the table gets the update. So here you have one insert. Here you can really think like an Oracle database, Alice1. Now you have Alice1 and Charlie1. And here now you don't get a new event, but you get an update for the Alice1, right? Under the hood, this is still also a topic. So it's still event-based, but it continuously updates to the most recent version of that. And so with that, you can build stream table joins. And so you can build applications which use both streams and tables. Like we will see in a minute in a clickstream demo, where you can think about the stream as new clicks on the website. Every click is a single independent event. And on the other side, you have the user data, which stays consistent. But for example, you count the clicks per user, right? So that's how this works together. But it's both natively built into Kafka streams and KSQL, so that you don't have to use an external storage or in-memory data grid or whatever you want to integrate with that. So for the syntax, here just more or less as reference. So you can do interactive queries. You just like select commands, as I will also do in the demo. And that's great for data analysis, for debugging, for consuming some messages in a UI, right? That's great for that. But then in the end, what you want to do with that also is you really want to build new streams. Create a stream means that there is a new stream which is then continuously processing data in a KSQL engine. And the same also true for the table, of course. Right? The syntax is a little bit different, but that's the main three things you do. Either you do select queries to interactive analyze things, or you create new streams or create new tables. That's the three things you more or less do with KSQL. And then, of course, you have, again, like for Kafka Streams, the features like windowing. That's important if you want to do more powerful things like counting or aggregation, as we saw in the fraud detection example. So there's different window concepts. I don't even want to go into too much detail here. You just have to be aware of that's like any kind of stream processing application. You have different options of windows, how you aggregate data. So in the second live demo, for example, we will also see a session window where you monitor session data from the different users and say, okay, this web user logged in and now his session is open for 200 seconds. If the user doesn't do any action, then the session closes. That's one window, right? Or the tumbling window is you always monitor 5 minutes, depending on what you want to implement. So let's now take a look at a demo. Here is in the end what I do to start the demo. Here I assume Kafka is already running. So right, KSQL connects to an existing Kafka cluster. It's just another client like Kafka Streams, like Java, like .NET, like all your consumers and producer applications. So we first start the server, the engine, and then we use the command line interface to send queries to it. Again, I will talk more about the architecture and deployment after the breakdown. So here is really just now learning about the syntax and understanding how that works in general. And we will use the clickstream demo. That means we have users. This is in the end a table with user information, which can also be updated via events, but only stores the most recent information about each user. And we have the page views. That's the clickstream. Every click is its own event, completely independent of each other. And with that, I will show you now a few different things, but that's now what I will do with the command line interface. And I will also show the KSQL UI. That's what we have today in an experimental version already. You can get that from our website. For me, as I'm not the most technical person, it's often a little bit easier to use a web UI with copy-paste and so on instead of a command line interface in the terminal. But here, in the meantime, we don't have that many more options, a few cool things to create streams easier. But this will get much more powerful in the future also. And this is already available on our website, and we will also give this in a freemium version away in the future as part of a freemium control center. So it's not just in a proprietary version. So with that, let's take a look at the demo. This will be a little bit harder with microphone and typing. But let's see if we can see. No, we cannot. I have to stop this one here. OK, so here we are. This is my command line. And what I will first do, so I have nothing running here. I'm really starting from scratch. Even Kafka is not running. So what I'm using is Confluent command line interface. That's also an open source command line. Here I can ask for the status, for example. And you can see all the different Kafka components are down. So let's first start some of them. This is in the end just a simpler thing instead of using each command by itself, which you want to use. You lost the Hangout again? Oh. Let's see. Share screen again. Maybe it always when we leave. So now we are back probably. So okay, so here I say start schema registry, for example, without a typo. Start. And then it starts the schema registry and all its dependent components. So first it's starting with Zookeeper, which you always need for Kafka, and it's then starting the Kafka broker. And that's simply a pretty cool tool if you're just locally on your laptop and want to develop things. That's also open source. And for playing around and learning Kafka, it's much easier than using a lot of different scripts for starting that. And you can even connect to Kafka Connect. And so if you just type Confluent, and it's also just in the beginning. So this is also getting better and better all the time. So with that, let's check the status again. We will see now Kafka is running in Zookeeper. So that's in the end what we need, and later also the schema registry. By intention now, I didn't also start the KSQL server because I also want to show you the second option. And I will also use a lot of copy-paste here because it's with one hand, it's not that easy. And it's faster for you. So you see here, I have a configuration file for my KSQL engine. That's in the end where the Kafka broker is running here. It's more or less default values. And with that, let's now start the KSQL runtime. So here you see this is one command, KSQL server with the properties file here. This takes now a few seconds, and this is in the end starting the Kafka Streams engine. This is a Java process under the hood, which is now running locally on my laptop. It could run in Docker, Kubernetes, or wherever. And now the KSQL engine is running, and with that I can connect to it to create new queries. You can either do that via the command line interface or via the UI. So let's take a look at that. So here first I have to open a new tab because the other one is of course now continuously running. And so here we are connecting. You see here is the KSQL command, and I say, okay, this is my address for the KSQL server, and now I'm in there. This is my command line interface. And for example, now I can list all topics. This is all Kafka topics we have in this Kafka broker. This is not really much yet. This is just 2 internal topics because I'm starting with 0 from scratch. We don't have anything yet. And I can also do the same from the web UI. So let's also do that. And we can use whichever we like more. Let me see. I hope I don't lose the Hangout again. Okay, so where are we? New window. Okay. And here we are. Let's make full screen also. So here you see the KSQL UI. And here you can also do your queries. As I said, the good thing here is already you have a few things that you can do some things easier, like the default values. Okay, and so here, for example, it shows the screen. It's not a perfect resolution, so I will probably mostly use the command line interface. But in any way, it's the same results here, right? What you do. So the query, the KSQL server. And now let's do some stuff here. So the first thing what we also can do, so this in the end is just Kafka under the hood. So we can also still use any other technology which we know. So here we have just the simple command line, Kafka topics. And this is also working the same way, right? So you can still use the other technologies. And in the same way then, when we create KSQL queries, it sends the output to another topic, to nothing else. So you can use any other Kafka application again to leverage that and read from the other topic. So with that, what I will now do, I will create some test data. So KSQL also creates a cool data generator. You can also use that, even if you don't use KSQL, or this simply generates some data. I configured it here so that it creates some users, and then also the second one that it creates some clickstream. And this is continuously running, and this is really great for development and for testing and so on, because in Kafka it's much more fun if you have really streaming data, especially if you want then to use KSQL. So these two are now running really in the background until I stop them after the demo. And here you see this is now the users. And with that, let's now do something. So you can see here, I could also use again the Kafka console producer in the normal terminal, but let's skip that. And now let's, for example, what's also cool, we can also print the data. So as I said, the KSQL UI or command line interface, it's also just cool if you want to debug or consume data. It's simply much more beautiful than writing some code somewhere to do that. So for example, here I can print page views. And here now you see, of course, it's too much here, so let's cancel. Here then you see the different information of the topic when you consume it. But now let's really do some new stuff. What I do here, I create a new stream. Let's now go back to the command line interface because it's the better resolution. So here we are in the KSQL CLI, and we will create a stream. Here now you see we create a stream and define its structure. So this is what we have to do if we are using JSON or delimited. So right now we support 3 structures. Delimited, which is comma separated or somehow separated. CSV files, for example. We have JSON and we have Afro, right? That's the 3 things which are supported today. Hopefully we will also get other things like protocol buffers or so. But for now, that's the 3 we have. And this is the limited data, and we have defined the structure for this. This is needed because now, and as I said, as I have just one hand, I'm more or less copying everything that's easier for you or faster than I type with one hand. So here we show the streams. Here just we have one stream with the format delimited, and then we can also describe the stream. With that, we will see the structure of that. And that's important that we have the structure in here because then, of course, we can do the queries and joins and aggregations based on the structure. So this here looks the same, no matter then if you have delimited or JSON or later Afro, right? You have the different attributes, and you can use them for querying them and so on. So let's now do a query. Here we select the stream, and guess what? So here I have limit 10 if I don't do that. And that's the important thing about KSQL. In the end, KSQL is built to deploy continuous stream processing. So if I run it this way with a semicolon, then this one runs continuously. This doesn't stop because we are not implementing request response. We are implementing a continuous query, which we want to deploy later for mission critical production. Right? So I have to do Control C to stop it. And therefore, for interactive analysis, we could also use things like with limit, if you want to just see some of the data here. So now it stops after 10 for that. And this is to select data. Again, the three things are create streams, create tables, or just do selects to do interactive analysis with that. And so now we can do the list topics again. So with that, we will see that now we already have a few more topics. So here you see we have especially the page views and users topic. This was created by our data generator before. And now let's also create a table. You see here the table again in the same way, because this is JSON data in this case, from the user topic. So we are using the data from the users topic and create a table out of that with this structure here. And then in the same way, like with the stream, we can query that. So first we could show it, but it's always the same. And then we can select star from here and query the data again. The point here is, again it runs continuously, but the point here is you only always have the most updated version. So the user 5 right now has the region 6. And if this is updated with a new event, then you would only have the newest event, a new region, for example. In contrary to the stream, you only always store the most recent data. So it's really a table which you have. It's a stream, but in the end you only store the most recent version in that. And that's then what you can also leverage to do joins and so on. So let's create one more table here. For example, we want to create another table. We are now building more and more stream processing, like filtering or so. This is, of course, relatively simple examples. I will show you more advanced ones in the second demo later. But here you see now we are creating a table female users as select from users original where gender is female. So in this case, we are not using an already existing Kafka topic to consume, but we are using an existing table, which under the hood also uses a Kafka topic. And with that, we have here the filter as a very simple ETL example. And with that now, if we take a look at list topics again, you can see that this is now also creating a new topic. So here we have the topic female users. So here you see we created a new table which we use for streaming and so on. But in the end, it's a topic under the hood. So this female users, which is the result of our streaming ETL, simple hello world streaming ETL, this now again can be consumed by any application because it's just a new topic. So any other Java consumer or other application can now consume this again. And this way we build, in this case, pipes and filters, but we build streaming applications which can do use the things. And let's print it one more time. So this is again here pretty nice. Let's clear first. And here you see again, this is the print. So you can also show the content here. And I'm almost done with the first demo. One more important thing, let me just, I'm not sure if I need this one. So let me just create one more stream here. This one stream is with a left join here, so here you see a little bit more powerful example, where we do a join between two different things and create a new stream again, page views by female user. But what I want to show you at the end of this first demo is also the Afro integration, which we also had discussed before. Because with Afro, we don't have to define the structure when we create a stream. First, I need to create some new test data. This is now.
What does it do when you leave joins?
Sorry?
Because it's a live stream, so join to streams.
It joins the stream with the table. So the table is there, in the end the stream is joining with the table.
The whole table?
If you, for example, have a stream, if you have a table user,
Scan the table all over again.
it only has the most recent event for everything, yes, but it scans it all the time. So let's say it has the user is the table, right, and it has an ID. User ID 1, user ID 2, and so on, that's the table. And then the stream comes in, and for every event, if you have a join with a specific user ID, then you join with the user ID 1 and do the join, and that's the result. If there comes a new event, and the table could already have been updated, so it's always the updated version, yes. With every new event coming in from the stream, it's always joining with the newest version of the table, because both are streams under the hood.
Global table? Kafka still global table?
No, it's not a global table, I think, from the implementation, but don't me ask the details. Okay, so here now I'm creating some new test data and one more. And with that, I will show you the Afro integration, which is also pretty cool. So here it's creating more data. So here now we are creating ratings. So based on our click streams, we are now also creating ratings. So let's take a look at the ratings to see what we have here. Print ratings. So here we see ratings. So in the end, here you see how many stars and then some text also here. That's the new information we have in a new topic. So we can also do list topics again. List topics. So here now we also have the ratings topic, right? And the point why I did this here is that now I can create a stream of that. And the great thing is what you will now see here. Let's clear it. Here now we can create a stream without defining the structure. And that's possible because here we are using Afro, right? So because it's Afro, the structure is already defined. And so we can create new streams on that without defining the structure in this line here. If you remember from before, from JSON and delimited, we had to define the structure here. But with Afro, that's possible without doing that. And though you can very easily create new streams based on Afro without defining the structure all the time. And that's also pretty cool. So here you can see now, if I describe these ratings, then you see here, even though we didn't define it here, here you see the structure within this stream, right? And now you can query it again. So let's do this as last thing of the first demo. Select all ratings where the stars is smaller or equals 3. And here you go, right? You only see a rating smaller than 3 in this continuous stream. And that's pretty cool with Afro integration, I think. And still, this is just the beginning. So we will do many more cool, powerful things. So for example, right now, some of our engineering is working on Kafka Connect integration, so that you can even do integration with Kafka Connect things in one command line, in one line of code or so. So this is really getting cool, but that's the future in the next months. This is what it is now, and so that's pretty cool already, I think. With that, this is also the end of almost the end of the first demo. What I will now do, I exit here, so I go out of my command line interface, and I stop all